Can you believe that Threadripper 7000 launched in November of 2023, and here we are with the launch of the Threadripper 9000 series? This is our Linux-focused video. If you're more interested in Windows, gaming benchmarks, that sort of thing, check out the Level 1 text review, but this is Linux, and AMD has really opened up the possibilities on this platform. Even if you've got a Threadripper 7000 series CPU and you have no plans to upgrade, good news, that Threadripper 7000 series platform also got some major upgrades with the release of Threadripper 9000 series. You're probably going to want to update your BIOS. Bottom line, 25% performance increase, especially if you're running AVX 512 workloads. Can even be a little beyond that, but average server workloads, 10 to 15% for pretty much all other workloads. So it's a substantial generational lift. But the platform features, come for the performance improvements, stay for the platform features. Join me. Let's dive in. Okay, so you should know that for this review, I've gone a little off the deep end. These are the boards that we have had at TRX50 for the launch of Threadripper. And Threadripper and TRX50, this is a 4-memory channel platform. This is designed for 24, 32, and 64 cores, the X series CPUs. You can use Threadripper Pro CPUs in this motherboard, or the TRX50 motherboards in general, I should say. But I don't recommend that. It doesn't make sense. The whole reason you buy Threadripper Pro is to get 8 memory channels of bandwidth because you're running fancy pants AI. And that's really the only thing that TRX50 loses out on. I mean, don't get me wrong. The memory subsystem has been upgraded dramatically on TRX50. Officially supported from AMD this time around is JetX 6400. When TRX50 first launched, Threadripper 7000 series CPUs could do DDR5 5200, which is pretty I mean, that's fast, don't get me wrong. But it's kind of weird because the JetX standards were 4800 and 5600, and 5200 was kind of in the middle. And those Threadripper 7000 series CPUs, they're still qualified and supported for DDR5 5200. But I have some good news. Our motherboards that launched from launch day. Some of these are from launch day. I've got actually multiples of these boards because we're crazy people here at Level 1. You should see the projects over on the forum. I mean, you know how it is. And so this is our launch day TRX50. Well, this is actually about a month after launch day. This is actually Rev 1.1 of this board. And Rev 1.1, as you know, if you've followed my content for years, we had some problems getting the memory to overclock on this. I mean, 5200 is fine, but Gigabyte says that it should work up to 7600, something like that. Had a lot of problems with that on my 7000 series CPUs. Since the platform updates, it's much less of a problem. I can do 6400 on this board stable now, even with my 7000 series CPUs. And that is an overclock on the 7000 series CPUs. But we're here to talk about 9000 series CPUs. The 9000 series CPUs officially support 6400, and you can go even beyond that. I've done up to 8000 on the TRX50 platform, but not on this motherboard. The Asus Sage Wi-Fi, I've done 8000, and the ASRock TRX50 WS, I've done 8000. The most unlocked BIOSes for Linux, for all of the AMD, CBS, and PBS options, not Asus, it actually hides some CXL options. It is the TRX50 WS from ASRock and the Gigabyte Aero D. These are pretty much your only options. Yes, I'm aware of the Gigabyte AI tops, but the CPUs like these, Threadripper X series CPUs, these will only work with 4 memory slots. It doesn't work with 8 memory slots. You don't magically get 2 DIMMs per channel on that motherboard. I'm sorry to let you down. Now, Linux. Back to Linux features, and I'm sort of kind of bleeding into this. All of these motherboards, including the Asus motherboard, have a lot of these options unlocked, and you can do basically everything. The only option that I didn't see in the Pro WS TRX50 BIOS for Asus are the CXL options. CXL works on Threadripper. I actually did a different video on that, and that works on 7000 series CPUs because, again, the platform updates here, they've accidentally or on purpose unlocked some functionality. I don't believe that CXL is really officially supported. It really only works in one slot on all 3 of our motherboards, and it ideally is a CXL device that is designed for use with 16 PCIe Gen 5 lanes. There's a forum thread about that, and the CXL devices that I'm using are the Smart Modular Memory Expansion devices. A Smart Modular has a 4 DIMM slot CXL expansion module, but that is really 2 X8 devices on one PCIe card. And while you can enable PCIe bifurcation, that is tougher to support on TRX 50, and so I don't recommend that. They've got another one that is a single slot. It's a single controller. That's about what you're going to be able to do in a single slot. And really, this is just a keyhole functionality. So like I say, this is not really officially supported, but it might be useful to people that are working on systems or enabling it or whatever. Now, if you run it in PCIe device mode, like if you set the BIOS options so that you treat CXL not as system memory, but as a specialized memory device, both of the smart modular CXL memory expansion modules that are for sale on Mouser actually do work. Now, the other thing that this platform enables, which is awesome, is AMD HSMP and eSMI. So take a look at our screenshot here from eSMI. This is showing the DDR5 memory bandwidth, the maximum fabric bandwidth based on how the processor is configured, the number of joules of energy that our processor is using, which cores it's using. It also shows what the turbo stats are for each core and why each core is not able to boost. This interface, the mailbox interface that registers the control platform that is here in this kernel module in Linux, is everything that we need to build a Ryzen Master-like piece of software for Threadripper. This functionality was enabled a couple of months ago with the platform updates again, and that is awesome. It is amazing to see AMD not keeping the platform as locked down as perhaps they should. I'm going to investigate the SEV SNMP, so like secure encrypted virtualization. I think that also works too, but it's sort of tricky to test that. It seems like that's going to work. I don't know. Don't quote me on that. But if you know how to test that and you want to, help me figure that out, you should hit me up in the forum and do all that in addition to all the performance insanity, because everybody else is covering the performance insanity. That's fine. The other thing with eSMI is it shows you how much PCIe bandwidth you're using, and I discovered something interesting when I was doing the comparatives. So these are the RTX Pro 6000s. These have 96 gigs of VRAM. I have 2 of them, and they can do PCIe Gen 5 peer-to-peer communication. NVIDIA's doing this weird thing now with 5000 series cards. I don't think they don't, in the documentation it says peer-to-peer communication is not supported on like a 5090 GPU. I think it still works anyway in most software, but I did discover an anomaly on Xeon when I was comparing against Sapphire Rapids and Sapphire Rapids Refresh, because I wanted to see how the new Threadripper were stacking up against Sapphire Rapids Refresh. Spoiler alert, not great. Really hope Intel is able to pull out a win with Xeon 6, but as of right now, this is the dominant computation platform by a country mile. I mean, it's pretty much a choice of Threadripper or Threadripper Pro or Epic. Like, which one are you going to get for your workstation? Anywho, the Xeon platform, for some reason, this could be an NVIDIA bug, has problems with peer-to-peer communication. These top out at about half the speed they should on the Intel platform versus the Threadripper platform. And of course, the Epic platform is even faster than Threadripper still. I mean, when we're talking about 12 memory channels, like the Epic 9575F is a monster, insane CPU. I actually want to do a separate video because you might be better off getting the Epic 9575F, especially for like AI workloads, even than Threadripper Pro. But that's a different video, and you should hit me up in the forum if that tickles your fancy and you want to discuss that, because I'm sort of figuring out how to cover that topic. Anyway, back on task. Threadripper, TRX 50, high-end desktop. Does this make sense as a high-end desktop option? Well, the motherboards are still really expensive. The RD RAM is disproportionately expensive. I reviewed 2 kits from vColor, one DDR5 8000 and another one 7200. The 7200 comes with heat spreaders, runs really well. This registered DDR5 memory, even DDR5 on desktop, because there's a thread on the Level 1 forum that talks about people that are mysteriously losing performance, and it turns out it's because their DDR5 on desktop was actually overheating because it'll silently throttle. I also tested G-Skill's 6400 kit. G-Skill's 6400 kit is definitely the choice. That was AMD's choice for the review kit, and it makes a lot of sense to me. These don't throttle. They generally hover around 60 degrees C. They will throttle if they get up to about 75 degrees C. They start to throttle, as reported by Hardware Info 64. The vColor 8000 modules throttle really, really easily, and I'm not sure that their temperature is reported. So depending on the brand of module and some other parameters, your mileage may vary, and so I can't give you really a hard and fast rule. It's like, oh, if you see 70 degrees C, it's not going to throttle, because that's not true of every DDR5 registered DIMM that I've tested. It varies even from kit to kit. Like Nemix RAM, which is like the cheap stuff, I've got one kit of Nemix that throttles at like 62C, and it's made from like the leftover memory chips. And I've got another kit that was ordered like 6 months later, I think it's even the same part number, or very close to the same part number. It was the same, it was like reorder this on Amazon, and what showed up doesn't throttle for like 70 degrees C. It's weird, I know. So that's something you have to keep an eye on if you're doing a build. We have lots of build guides if you're looking at putting together a system like this, or you can go with a system integrator and do that. That's completely fine. But it's really something that you have to look at when you're putting a system together like this. Do you want to go ahead and go with Threadripper Pro? If you're going to be doing AI stuff, the extra memory bandwidth can make a big difference. These CPUs are monsters for AVX512, which we'll talk about a little bit more in the benchmark section in just a minute. And AVX512 can also be a monstrous thing for CPU inferencing. But the weird thing is that it's kind of frontier science. It's kind of frontier, like running AI on a CPU. Nobody wants to do that because it doesn't really scale super well for multi-user. But if you're just a single person, a single researcher, or a single person working on messing with this kind of stuff, it actually does scale pretty well for a lot of cores. So on Epic and Threadripper, me running stuff, not even small quantized model in systems that have 512 gigabytes and a terabyte of memory, you can run pretty well directly from CPU, and that is an interesting use case. The problem is that TRX50 only has 4 memory channels, and so you top out at about 200 gigabytes per second. This is about as much bandwidth as you get from AMD's Strix Halo platform. And the cost of memory, the cost of RDIMMs, 128 or 256 gigabytes of RDIMMs right now is ludicrous compared to desktop memory. You get 128 gigabytes of UDIMM memory for $300, $350, $400. Even SODIMMs, 128 gigabytes of SODIMMs for $350, but it's going to cost you well over $1,000 right now to get 128 gigabytes of RDIMM. And I think this is partly tariffs and partly supply and demand. I'm not really sure, but that is crazy expensive. It should not be that expensive. And because you've only got 4 memory slots to work with on TRX50, where you've got 8 on WRX 90 on the Threadripper Pro platform, it's a little easier because it's like you can order 428 gig DIMMs, which will get you to 512 gigabytes, but that's quite a bit more expensive than if you could just get 8 64 gig DIMMs on the WRX 90 platform. So you see, it's a little weird. Check out our build guides and that sort of thing for putting this together. So let's dive into the benchmarks and talk benchmark specifics. The gen-on-gen uplift really is not too surprising here if we look at the benchmarks. I mean, Mini-Butte, I did some different configurations, some different options for it, and the 9980X is just dominating on Linux. And I really, it sort of juxtaposed this Linux versus the Windows benchmarks, because Windows still struggles with the whole 64 cores, 128 threads things. Like the scheduler is still not where it should be, as evidenced by the massive generation on generation gains that we see here in computational workloads. This is all AVX512. This is an AVX512 benchmark through and through, and the 9980X is just destroying everything. The 9970X is as fast as the 7980X, very nearly so. That's a doubling of performance because, again, AVX512. It's not quite as brutal if we look at NAMD and Spec FEM3D. This lines out about how you would expect. The 9980X and the 9970X here are doing very well. LuxCore render. From the 7980X to the 9980X, the LuxCore render doesn't show as much of a gen-on-gen gain. I suspect this is because this render is not using AVX512. Perhaps there's room for optimization here. Embry is kind of the same story, as are a lot of our other benchmarks. I was a little surprised that our SVT AV1 encoder was able to encode faster on the 9970X. But I have a feeling that's because even though this is an input 4K, this doesn't scale well to a lot of cores. This is one of the kinds of benchmarks that would scale well if you were running multiple instances of it across the CPU, but this is just one instance. And so if you look even at the 7970X, it's not a fully loaded CPU when you're running this. Same thing is true with HEVC and VP9. They're just different codecs that stress the CPU in some different ways. UVG 266, same kind of a deal. The 9980X pulls a little ahead of the 9970X, but this is really not a huge difference between all of these. Timed Linux compilation, all mod config, 228 seconds on the 9980X. An LLVM at 105 seconds on the 9980X versus 145 on the 9970X. not bad. Decided to run some different level DB tests for random fill. There's really not a huge performance difference on any of our CPUs. The random fill benchmark in terms of megabytes per second really wasn't hugely different, but then if you look at the microseconds per op, where fewer is better, the 9970X and the 7970X were better than the 7980X and the 9980X. It's an interesting aspect of this benchmark, I think. The bird strike on the windshield test in Open Radios, the 9th generation, I mean, this is some pretty good performance uplift gen on gen. Talking like 25, 26% here, gen on gen, and this is a simulation benchmark, so I mean, obviously there's AVX 512 benefits here, but also 7-zip, the 7980X and the 9980X doing really well here. Not a huge difference. There is a little bit of a performance uplift over the 9980X, and I think this is somewhat to do with improved memory bandwidth, but not huge performance differences between 7th and 9th generation. And this sort of reinforces my thought that unless your workload really heavily depends on AVX 512, there's not anything hugely beneficial from moving from 7,000 to 9,000. But if you're on Threadripper or Threadripper Pro 3 or 5,000, there's some pretty compelling reasons to move to 9,000 if you skip the 7,000 generation, or if you skipped more than one generation, or you're still on a Xeon workstation. TRX 50 does fit for some of these workloads really well. Like photogrammetry doesn't really scale all that well when we're talking about memory bandwidth. AI is the workload where memory bandwidth scales dramatically, but there are all these other workloads where it doesn't matter quite as much. If you're running DaVinci Resolve, and especially if you have something like the Blackwell, the RTX Pro 6000, this is hardware 422. DaVinci Resolve on something like the RTX Pro 6000 plus a Threadripper platform with its monstrous AVX 512 capabilities is an editing platform that is second to none. 96 gigabytes of memory. You want to talk about capacity and storage, Linux MD is great. You don't need AMD's RAID. A lot of people in our forum are rocking things like this, which is perfectly fine. This is a 4 M.2 PCIe card, and this will give you, it'll convert one of your slots into 4 M.2, and this works great. This works great with the Asus motherboard. This can work great in the Aero D. Just remember that your bottom slot is only PCIe 4, not 5. This thing is set up with Crucial T705s. This is what we used in our benchmarking for things that needed really fast storage, but on the Asus and the ASRock motherboard, because it has the MCIO and SlimSIS breakouts, you can also run storage like this. This is the Solidigm 122 terabyte U.2. And so you can get a cable to go from the motherboard to this and use this as storage. And this is 122 terabytes in this tiny little 2.5 inch package. It's really made for bulk storage. You can get U.2 that is faster, but 122 terabytes is absolutely insane. Basically, this is the $5,000, every component is $5,000 build guide for Threadripper. You get the $5,000, oh no, actually $10,000. You get the $10,000 RTX Pro 6000, the $5,000, oh no, it's more than $5,000. Storage, you get the $5,000 64-core processor, you get $5,000 worth of memory, because you're going to get the fancy memory kit. It adds up. It adds up really quickly. And so because of that, I'm hesitant to call this an enthusiast platform, but you still can get, 7,000 series CPUs in the secondary market. Maybe somebody's upgrading from 7,000 series to 9,000 series, and that makes sense for, certain kinds of workloads. And then you can get a good deal on those CPUs. Personally, I think that if you're on 7,000 series Threadripper, unless your workloads need AVX 512, you could probably hold off a generation. If you're on a Xeon workstation, like a 5th gen or 4th gen Xeon workstation or older, or you're on Threadripper or Threadripper Pro 3000 or 5000 series, this may make a compelling upgrade. If you make money with your computer, or time is money, or the computer doing things faster makes sense for what you're doing, then this is a no-brainer. Once you experience the joy of computing with Threadripper in a Linux context, being able to run virtual machines, being able to do creative workloads, being able to do video rendering, or 3D rendering, or modeling, or even assigning half of your cores to do rendering while you keep on working, which is a thing that I didn't think computers would be able to do in my lifetime, at least not a single standalone computer, because everything else but these handle it well, then Threadripper is for you. AMD has executed on their roadmap more consistently than any other microprocessor manufacturer on planet Earth. And that's true whether we're talking about x86 or ARM or or anything. There's like, this is what we're going to do. This is the cadence in which we're going to do it. And they have. It hasn't always been easy. It hasn't always been, perfectly smooth. It's been a little rough around the edges at times. But this, as an update to the TRX-50 platform, if you were hesitant to jump on the TRX-50 platform because of teething issues, because of its new platform or whatever, 9000 series is for you, because this is more mature on launch in the BIOS and the features and everything else than I've ever seen. And it's nice to see AMD have enough confidence to at least give us a little bit of a keyhole for some of the more advanced technologies. And they might not officially support things like CXL or like some of the other, like off-road stuff that we love to do here at Level 1, but they are confident enough in their product to unlock that, to let enthusiasts like us, because I am enthusiastic about those technologies, to be able to play with the knobs and levers that are in otherwise unaffordably expensive products. And this is something that I think Intel has missed out on with their accelerators. A lot of the accelerators are only available in the true Xeon server parts and not the workstation parts. And I think a large part of the reason why those weren't adopted as widely as perhaps Intel would have liked is because developers couldn't get at them in their developer workstations. They had to remote into somewhere else. And I know things are a little different now than over the last 10 years with the cloud, because like the developer can deploy the cloud workstation workflow and experience the joy of their computer doing some stuff with a remote computer somewhere else and get the stuff back from the job. But that's still a little rough around the edges in terms of the developer experience, even for the best cloud experience. I mean, even AWS CLI and those kinds of things are not perfect experiences, Azure, whatever you happen to be running. Bottom line, TRX-50, this is a significant update. And the only real danger here to AMD is that everybody is going to expect these kinds of upgrades in performance and everything else every single generation. And if AMD can deliver on that, great. But if not, people will be disappointed. But for Threadripper 9000, there's really not a lot to be disappointed in. It might have been nice to move to a 6 memory channel configuration, or to have some kind of an option for AI, or surprise, you can use these CPUs in WRX90 motherboards now with 8 memory channels, but I don't think in terms of manufacturing or qualification or anything like that, that those options were really realistic. Who knows what the future holds, but for now, TRX-50, breathtaking performance for the AMD 9000 series processor launch. As I said, it's over 9,000, literally and figuratively. If you have any questions or workloads that you'd like to test, hit me up in the forum, because we do that kind of thing. It's like, hey, run this thing. How do you think we got our photogrammetry tests? Thanks for the help for that on the forum. It's some forum helpers. So yeah, I'm Wendell. This is Level 1. This has been as quick a look as I know how to do at Threadripper 9000, the 32 core and the 64 core. A lot to be excited here, if you're a Linux user especially. There's so many updates in the Linux kernel. I mean, Zen 5 was basically built for servers and Linux and all of these heavy lifting workloads, and Linux is really coming into its own as a desktop operating system. I love it. All right, I'm signing out, and you can find me in the Level 1 forums.